Hello everyone, I am N. Prasanna Venkatesh, going to present my work on Airtel features based prediction of sinus data using LSTM RNN model. The main motto or background which motivates us to start this study is that occurrence of tachycardia in atrial fibrillation. And moreover, atrial remodeling happens in any type of atrial arrhythmia, mainly atrial fibrillation. So we started getting insights of atrial features and tachycardia or heart rate to predict the tachycardia conditions. So to develop this study, we follow the methodology of started from data collection, feature set, and statistical analysis. So we recruited population of 10 healthy volunteers with a mean age of 26, and this recruited population is used for recording a sinus rhythm and sinus tachycardia. And the study only focus on sinus tachycardia to predict the tachycardia condition. To compare the data from tachycardia with the sinus rhythm and abnormal atrial fibrillation. We recorded the sinus rhythm, and also we include data of 10 AF data from Chapman University and Shoxing People Hospital with a mean age of 76. The feature set mainly focusing on sinus tachycardia, which to get more insights on atrial activity, we include more atrial features like P wave amplitude, P wave area, P duration by amplitude, P area by duration, and AV ratios like P to QRS, P to peak ratio, along with R intervals. The statistical analysis starts with the testing of normality using Schaefer-Wilk test, and after understanding the normality, we go for a Pearson distribution or Pearson correlation, and significancy test is performed with 2 sample t-test, and data are represented means plus or minus standard deviation. So the model or architecture which we used to develop a model is LSTM or RNN. LSTM is nothing but long short-term memory recurrent neural network. Which has 4 different gates shown in figure 1: forget gate, input gate, output gate, and output gate. And here X is the input, Y is the output, and C is the upgate. And CT minus 1, YT minus 1 are from the previous LSTM architecture. So the total model which we developed consists of a LSTM layer, dropout layer, and a dense layer. Before training a model, we scale the model using min max scaler. And before going for the model result, we discuss the results of statistical analysis. So table 1 shows the comparison of SR, ST, and AF in terms of heart rate and PV amplitude. Here SR and ST is significantly different, and SR and AF is significantly different. And the point which we come to know is that there is a proportional increase in of atrial amplitude with the heart rate in ST, and inversely proportional thing is happening between the atrial amplitude and heart rate in atrial fibrillation. So which is clearly seen here that there is a very decrease in atrial activity since the P wave is converted to F wave. So and with increase in heart rate. With this increase in heart rate. Similarly, but in sinus tachycardia, the atrial amplitude increases with increase in heart rate. So finally, to get more insights on atrial activity, we compare with more atrial features, and table 2 shows that heart rate, RR interval, P wave amplitude, P wave duration, P wave area, and PR interval are significantly different from sinus tachycardia, and this difference is due to the increase in the range. So finally, we see the output of LSTM RNN model. The LSTM RNN model trained with 50 samples with the trained test split of 70-30. The model's output is measured using a mean square error, and loss rate curve is plotted in figure 2A, and predicted values are plotted in figure 2B. The training loss is about 0.827, and testing loss is about 0.1568. And finally, we want to discuss that the present work predicts the tachycardia using atrial features based LSTM RNN model. The main purpose of using atrial features is that atrial remodeling happens in any type of atrial arrhythmias, and moreover, from this overall results, phylogenetic standpoint, it is hypothetically plausible that people with tachycardia are more susceptible to developing persistent AF. And moreover, the prediction of tachycardia in AF may enhance the diagnosis of occurrence of AF in the paroxysmal stage. The present study is a preliminary study, and the use of LSTM RNN model works on the logic of multivariate time series forecasting, which forecasts the data from the past samples. And the key benefit of LSTM model is predicts the missing data effectively, which minimizes the false positive and false negative of predicting other arrhythmias. Thank you.